Stan Gibilisco here with installment number 8 in the complex number tutorial. The concept I'd like to describe here is the idea of complex conjugates. I'm not sure what the word conjugates actually would mean when I look it up in the dictionary. I remember it having something to do with language structure in foreign languages when we had to learn all these things. But conjugates in complex number terminology refers to pairs of numbers that are alike, that are identical except for one thing, the sign in the middle. A plus JB, where A and B are real numbers and J, remember, is the positive square root of -1, has a conjugate A minus JB. And conversely, the conjugate of A minus JB is A plus JB. These two are called complex conjugates. They have certain properties that are interesting and that make them useful in a variety of derivations of formulas in applied mathematics that involves complex numbers. First, let's see what happens when we add two complex conjugates, and we can just use the general forms. A and B can be any real number, including 0. If we add, we get 2A. But if we add these two, we get 0. So we get a real number when we add two complex conjugates. We simply get twice the real number, twice the pure real number part. Well, let's see what happens if we subtract them. Subtract one from the other. Well, if we do this, this second expression is the equivalent of minus A plus JB. And when we do that, we get 0 plus J2B, or the pure imaginary number J2B. That's if we subtract in that order. If we reverse the order of the subtraction, we're going to get minus J2B. You can verify that for yourself. Now let's see what happens when we multiply. Remember, when we multiply complex numbers, we're actually multiplying binomials by each other. The first term in the resulting polynomial is A squared. The second term is minus J. Let's do it like this for a reason here. Plus a minus JAB plus JAB. And then here we get plus JB times minus JB. Let's simplify here. Note that these two terms cancel. So we get A squared plus, now let's evaluate this. It's minus J times J times B squared. Well, what's minus J times J? but minus j squared j squared is a minus 1. So what we get here is a squared minus a minus b squared, or plus b squared. Interesting. Again, we get a pure real number when we multiply a complex number by its conjugate. Let's look at these this situation in a coordinate plane where we have the real number axis here and the imaginary number axis here. You remember how that works, how we can have a vector. Let's suppose we have a plus jb here. A minus jb is going to go down here the same distance from the vertical axis on the same side, the same distance from the horizontal axis on opposite sides. So if we have a vector like that representing a plus jb, the vector for the conjugate is going to look like the mirror image of that, as if the mirror were horizontal, like that. That happens no matter where these vectors go. If they both happen to be pure imaginary, they'll go straight up and down. If it's a pure real number, then it's its own conjugate. A plus j0 equals a minus j0. So that is an overview of what is meant by complex conjugates. That's all there is to this episode. The end of this episode. See you next time, whenever that is. Stan Gibilisco signing off.